Hello. So this video is about one of the most famous riddles in mathematics, which is called the 1000 Lockers Riddle. So basically this problem is about a school that has 1000 students and 1000 lockers, one for each student. So one day the teacher gathers these 1000 students and asks the very first student to go and open, let's imagine that these are the lockers. He asks the first student to go and open every single locker in the school, the 1000 locker. And then he asks the second student to go and close, the first one opens all. Open. The second one will close every second locker. The third one will close here or open, and here close or open, like every third locker. So, for example, if the third one, whenever he meets an open locker, he closes it, and if he meets a closed locker, he opens it. And the fourth one goes and open or close every fourth locker. And the fifth one goes to open and close every fifth one. So they keep doing like that until the last student, now number 1000, will go and open or close only the 1000 locker, the locker number 1000. So the question is, if they keep doing that from the first student till the 1000th student, how many lockers will remain opened? So as an engineer, you have to, whenever you're given such a question or riddle or puzzle or a problem, you have to put numbers and try it. So for the next step, we are going to try this riddle. So for the first column, here we have different number of columns and rows. For the first one, these are the lockers. Locker number, let's give them numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll try this riddle with the numbers from 1 to 10. So locker number 1 of them will be, let's say that positive, plus means open and minus means closed. It's not clear with this color. So this one is open, this one is closed. So as we said, the very first student, these are the number of lockers and these will be the students. The first student, second, third, fourth, fifth. Since we have 10 lockers, we'll have 10 students. 9 and 10. So the first one will open all of them. Positive, 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 positive. The second one is going to close every second one. So number 2, number 4, number 6, number 8, and number 10. So the other lockers will remain the same. This will remain plus, 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 and plus. The third one will change every third one. So this was plus, it will be minus. Number 6 will be, it was minus, so it will be plus. You have to pay attention for this one. 9 was plus, so it will be minus. And the rest will remain the same. This will remain minus, minus. These will remain minus. This one will be plus and plus. So you keep doing the same with the fourth one. Fourth one will change this one. Number 4, number 8. be plus. This would be the same. Number 5. So I'll keep filling this table and then I'll come back for you. Alright, so I've filled the table, and as you can see here, I made 2 mistakes, don't worry about them. As you can see, how many lockers will remain the same? We have 3. This one will remain open, sorry, not the same. Opened and opened. So let's take some notes. Note number 1, as you can see, for number 1, so let's write them down. Number 1 will always remain opened. That's the first one. The second one is that you can realize that the prime numbers will never remain opened at the end. Why? Because prime numbers will change once, will change twice. The first one will be when it's opened, and the second one it will be closed. Like the 7, the 5, the 2, and the 3. 2, 3, 5, 7. These are all. So this is note number 2. All prime numbers will be closed at the end. Why? Because they will change always twice, so they'll be opened once and closed, and they will never be opened again. So this solution, the 3 lockers, is when we have only 10, but the main riddle says we have 1,000. So how can we know the answer? Let's check the 3 numbers that will remain opened. 1, 4, and 9. What's so special about these 3 numbers is that they are false, they are full squared numbers. And as we all know that only, we saw that the prime numbers will remain closed because they'll be opened and closed. So they'll have an action twice. So we need an action to happen 3 times, or an odd number, generally an odd number, so that at the end we'll have a plus on this side. And the full squared numbers are the only numbers with the odd number of factors. Why? Because let's have the number 9. It has the 3 times 3 and 1 times 9. So it has 1, 2, and 3 factors. While let's say if we have 18, it has 2 and 9 and 1 and 18 and 3 and 6. That's 1, 2, 3, 4, 5, 6, which is even. That's why only the full squared numbers will have an odd number of factors. So only the fully squared numbers will remain opened at the end. But the riddle says we have 1,000. So how can we know the number of full squared numbers before the 1,000? It's simply we take the square root of 1,000. That's 31.6. That means we have before the 1,000 31 different fully squared numbers, like the 1, like the 1, the 4, the 9, 16, 25, 49, and we can know that the last locker that will remain open in the 1,000 lockers is the 31 squared, which is 961. So this is so that you can even solve this problem for any number of lockers. Let's say we have 100 lockers, so the square root of 100 is exactly 10, and this means that we'll have 10 open lockers if we had a summation of 100 student and 100 locker. It's really an amazing riddle. I wish you liked it, and it has a lot of like hidden stuff. Like on the internet, maybe you won't find this piece of information that all the prime numbers will be closed at the end, because no matter what, they'll always have even number, which is 2, the smallest even number. Actually, I'm not sure about this. Is it the 0 or 2? Different from, like, I think it's different from, depending on the book you're reading. So I hope you like this video. Make sure to subscribe and like this video. And if you have any puzzle or any problem in mathematics, physics, or electronics, you can comment in the comment section. And I'll see you in the next one.